Hey guys, in this video I'm going to walk you through a system that manages departments, employees, and project work and also enforces a budget constraint when tracking hours. It is a structured object-oriented system with custom exceptions and relationships between entities. I've included the full case study on the screen if you want to go through it in detail, but I'll break it down as I walk you through it. So you can pause the video for a minute or two to read it as to what we're trying to achieve. So let's break it down. So in this program that we have, we'll first start with the model classes, and then we'll move into the in-memory storage, followed by the functional layer where all the operations are handled. While working through the summary logic, we'll introduce a custom exception class to enforce the budget constraints. And finally, we'll look into the main function which ties everything together. So first we have the department class. This is a real simple entity that represents a department in the organization. Each department has a unique ID and name. You'll also notice a print statement in the constructor. This is just for debugging so we can see when the objects are being instantiated. Next, we have the employee class. An employee has a name and a department associated with it. Now, this is important. Instead of storing just a department ID, we are storing the actual department object. Now that means that we are creating a direct relationship between the employee and the department, which is a more object-oriented approach. We've also overwritten the str method. This allows us to print the employee objects in a readable format, right, showing both the employee's name and the department. Now we come to the most important class, which is project. And inside this parameterized constructor, we have maintained a dictionary called employee hours. Now this maps employee object to the number of hours they worked on that particular project. So instead of separating this into multiple structures, we are encapsulating the entire relationship inside the class project itself, which keeps it more clean and scalable. Now the and work method handles updating work entries, right? So if the employee is already in the project, then we increment their hours. Otherwise, we just create a new entry. And this ensures idempotent style updates. We are not duplicating entries, just updating the state, right? And finally we come to total hours method, which simply aggregates all the hours or sums up all the hours which we have right here. We use the sum function to aggregate all the hours worked on the project by summing the dictionary values, right? This becomes important later when we enforce budget constraints. Now let's look at how we are storing data in memory. Since this is a console-based system, we are not using a database. Instead, we are using dictionaries as our in-memory data storage, right? We have three dictionaries here: departments, employees, and projects. Now, departments are stored using an integer ID as key and the department object as the value. And in employees, they are stored using their name as the key, which is a string value. Now in real world systems, this would ideally be a unique ID because names can collide, right? And in the terminal, I'm going to make sure that we're going to have unique names so that it doesn't collide. And we're doing this basically for simplicity. And we are using names here. And right here, we have the employee object that we can map to, right? And finally, we have the projects dictionary, which is going to be mapped by their name, which is a string value, to the project object, allowing us to quickly access and update project related data. And right here we have the project budget, that is 150, which is a fixed business constraint. So if we go beyond this, we'll use it to enforce limits using a custom exception that we have right here, that is business exceeded exception. And finally we come to the functionality part. Now in add department, first we have a debugging print method, and then we ask the user to enter their name, and right here we have the maximum of all ID existing department IDs and incremented by 1. So if there are no departments yet, right, from the keys that we have, which is the IDs, so if there are no IDs in that department yet, the max returned will be 0. By default it is 0, and the first department gets incremented to ID 1, right? So once we have the new ID, we create a department's object and store it in the dictionary using that ID as the key. And finally we print it out that the department has been added. Now when we come to departments, we just print it out. So if there are no departments, then we just say that there are no departments and just return outside from the function. Okay, and finally if there are departments, then this is the structure that we print it out from, that for every department in each dictionary value, we say that this is the department ID and the department name. Right, now in add employee, first we have this debugging print method, which is not necessary, but I included it just to see the flow of control. And right here we ask the user to enter to the name of the employee, and thereon we print out the departments that we have. Right, why are we printing out the departments? So that the one who is controlling the terminal will know that after he has entered the employee name, I have so and so departments and I want to assign that employee to which department. Right, so that's why we just print out the list of departments and their IDs accordingly, and then we want to enter, the one who's controlling the terminal will, or the user will enter the department ID, which is the employee name going to be assigned to that department. Right, and that ID is going to be stored in department ID. Now we check with that ID if it is in departments, and if it is not in departments, then we just say that this is an invalid department ID or ID department name that you have provided, and we just exit out of that function or return outside the function. Okay, otherwise if the department ID does exist in the list of departments that we entered, then we will create an object employees, and once we have that name and departments with department ID, we want to assign that employee with the name to the employees object with the name as the key, and then finally we print employee added. Now let's take a look at list employees. Now this function is not just for displaying data, it's organizing employees department wise and preparing them for selection and other operations. Now right here we have the debugging statement. If we don't have any employees, it just says that we don't have any employees and returns an empty list, and then we come out of the function. Right, otherwise if it does have employees, then we initialize an empty list, and we're going to come to this later. It's basically going to be used to append all the list of employees, append it, and we're going to print that out. And this index is basically for indexing through those employees. Like, we're not going to use the department name because that department ID is going to be used strictly for departments, and employees don't have any IDs, right? But employees only have names, and so we're going to use indexing right here to sit right beside our employee name with the index that we have. Okay, one by one we're going to just print out all the employee names. Now notice here that instead of looping through the employees first, we loop through the departments first. So this basically allows us to group employees by department when displaying them, which makes the output more structured and readable. So we know that for each department, which what are the employees that we have, and or in we can say this like which employee belongs to which department, right? And we just print out the list of departments that we have, and we initialize the found variable to false, because we want to find what how many, or rather which employees that we're looping through belongs to which department, right? So inside the the loop for departments, we loop through all the employees and check if the employee belongs to that department, right? And that's because we store that actual department right here. While we were adding employees, we stored the actual department object inside the employee class. So we are comparing objects here, we are not comparing IDs. Okay, and then we just print out the employee with the index that we have right here, which starts from 1, and we append that with the to the employee list, and we increase the index to the next, so that the employee will have an increasing number of indexing. Okay, and then finally we just say found true. That means that employee was found in that particular department and it has been appended to the list. Otherwise, if the employee is not found, we just print out that there are no employees found and we just return from that empty list, right? And this is the way we have a structured and more scalable list of employees of way to display them, right? And then finally we come to our add work functionality. Okay, we have another show summary functionality. Now in the add work functionality, we first check if there are any employees, right? Because if there are projects and there is work, but if there are no employees, you cannot allot those projects or work to those employees because there are none, right? So we first check for employees, and if there are none, we just return outside the function. And then we have the list of employees that we want to assign to our employee list variable, which is going to be of type list, right? There we have it. And we're going to have a choice where we're going to select the employee ID. Now, as I mentioned, that employees do not have explicit IDs, right? So the ID that we're going to mention here is basically based on the indexing, right? So each index or each employee name that we have is going to be indexed with an ID. So then we assign that ID, or then the ID that we have seen on the screen, we give that choice as an ID, and that choice or that ID needs to be between 1 to the last of the employee list, right? And if it is not, then we just print out that it's an invalid choice and return outside the function. Now we have the user selecting an employee using an index. Now we subtract 1 because user input is 1 based, right? While Python lists are 0 based. And then we enter the project name and the hours, and that gets assigned to project name and hours respectively. Then we check if the project name that we have entered, if it already exists in projects, then we just we use that project, right? And if it is not in those projects, then we create a new entry for the project, right? And then finally we delegate the actual work tracking to the project class, right? Now this is add work, and this itself is also another add work function. Now this add work basically calls out to the add work method inside the project class. Okay, and please do not get mixed up with this add work method and the function that we see right here. It's not the same. Basically we are giving a dot operator here basically to call the add work function from the project class, right? And we are basically delegating the actual work tracking to the project class. So here we have the employee that we have, and the hours, the employee that we want to allot work to, and the number of hours that employee has to have to complete the project, right? And we assign that to the key of the project's dictionary, right? And then finally we confirm that the work has been allotted to that particular employee. Now we come to the show summary, where we want to print it out that which employee has how much work and what the budget constraints are going to be. Here we loop through the project object values and calculate the total using the total hours method that is present inside the project class. And then we move on to the try exception block. Now inside the try block, now notice here that instead of just printing an error or using a flag, we raise a custom exception. And this is deliberate. Why? Because exceptions separate normal flow from violation flow, right? Making the system easier to scale and extend. So if no exceptions were raised, we proceed to the normal case and mark the project as within the project, right? And if the exception is triggered, that is in this case, where we create an object E of the class BudgetExceededException, then we catch it and print a structured message using the data stored inside the exception object, right? Like we use the object to print the name and the total, and also that the budget has exceeded its value. Now notice that we are not crashing the program, we are handling the violation gracefully and continuing execution, right? Now inside the BudgetExceededException class, we are passing 3 parameters, right? The project name, the total, and the project budget. So we get inside the class, and here we have a parameterized constructor which initializes the project name, the total, and the budget, right? And notice here that budget exceeded exception class inherits the exception class, right? And the exception class provides us with common. It is a common base class for all non-exit exceptions, and it is a subclass or a derived class of the parent class called base exception, right? And it provides us with so when we want to make any create any custom exception, we always have to inherit the exception class, right? So that we can inherit its features, the methods that we want to inherit, right? And so overall, this block is responsible for basically summarizing project performance while enforcing business constraints in a control and scalable way, right? And finally, we come to the main method where we have multiple choices and that I am going to use in an infinite loop where we are going to get multiple choices to select from, and each choice is going to perform a particular operation that we have discussed above from the classes as well as these functions right here, right? Now allow me to run this project. So I'll just go by python index.py. I'll first add a department before adding any employee or any work to those employees. So I'll go for option 1. I would like to add 2 departments and 2 employees to both the departments. Say I have HR and I have engineering, and I want to view those departments and now add employees. So I'm going to add employees for, say, department, enter department name. Okay, how about we have another department? And now I want to go for option 3 to be able to add an employee, and let's add Dion to engineering department and add another employee, say Zara, and assign her to HR department. Now I want to view those employees. So the geological department has currently no employees, but the engineering and HR department has 1 employee each, right? And I'm going to assign work to both these employees. Now how about I assign some work to an employee from the geological department? Let's see what we get, right? So I'm going to go for option 5, and okay, so we cannot choose an employee ID because currently there are no employee IDs in the geological department. So hence we are using indexing here, and we didn't assign any what we call as IDs for each employee, right? We're using indexing here. So I'm going to add an employee ID, say 2 Dion, for a project name, say AI automation, and I'm going to seek the project budget by, say, 20, since the project limit was 150, right here. I'm going to exceed it by 20, and let me now go for, okay, what employees do we have again? 4. Okay, and what is the project summary so far? That there's AI automation and 170, and the budget is exceeded, right? Now say this is what we have basically printed out, that the budget was exceeded, right? Now we want to go inside the try block and see what gets printed. We want the within budget statement, right? So we want to go something with something below the exceeded limit or the limit, right? So I'm going to add another work entry and assign that to Zara with the employee ID 1, and project name would be, say, backend API dev, and I'm going to go for 140. So the project class has been called and added successfully. So let me have a look at the project summary. So it's within the budget, right? So that brings us to the end of this project. What we have built here is using object-oriented principles, enforcing a real-world constraint, the project budget, using a custom exception, right? And if you look at this from an industry perspective, this is essentially a simplified backend architecture. The only difference is that instead of a database and APIs, we are using dictionaries here, right? And a menu-driven interface. So I hope this was useful in understanding the design decisions here, not just the code. Till then, keep practicing, and I'll see you on the next one.